record. So good afternoon, everyone. No? Today is July 27. This is our third meeting. Okay, and I have shown you your assignment already, right? Do you follow? Now, may I remind you that the assignment will be due on Monday. Okay. So you have the examples here, no? And then you are supposed to pass a worksheet in Excel, no? A file in Excel with 4 worksheets. Okay, use pass it as extra1 underscore followed by your family name, your first name, and your middle initial. No? Make that a convention, no? Make that a practice to pass your, no? So that it will be easy for me to record the results in my class record. Okay, so the first is the sum of the first 4 numbers. It's not straightforward, no? It's not straightforward that you can convert the 4th factorial, no? You have to do some logical changes, no? Although it's not that difficult, right? Okay, Kenji Barrios, I don't know. So write a program to convert, but first, no, if you are able to write the non-loop version, it will be easy to convert, to write the loop version. No? Write a program to convert Celsius to Fahrenheit. No, it's the reverse of the example for the analytical engine, and save it to sheet 2. Program to compute the average, no, the first 3 numbers without loop, and write it to sheet 3. Program to compute with loop this time of the first 3 numbers for the analytical engine, no, and save it to sheet 4. Okay, the sum of the first 3 numbers, 1 plus 2 plus 3 divided by 3. Any questions? You follow the example, no? Now, the important, no, the special feature of our history here is this portion of our history is Ada Augusta King, Countess of Lovelace. No? 200 years na pala, no? No, that's more than, because it's 1600s, no? 400, no? So because she published a work on an application involving the analytical engine by Charles Babbage. No? So it was finished, the machine was finished in 1830s, the design, no? And when Charles Babbage published it in Cambridge University, nobody paid attention. Okay, the computing or the scientific community at that time were not interested in the result. It was first identified later in the 1930s by Alan Turing, by the way. No? So si Alan Turing ang nag-recognize ito during the 1930s. No? But during those times, no, only Ada Lovelace recognized the importance of his work. In fact, no, Ada Lovelace published, no, worksheet. This is the worksheet, no, similar to ours, no, except that there's no Excel during that time. No, published a worksheet involving the computation of generation of Bernoulli numbers, which has so many applications in math. No? Bernoulli series. No? Okay. So there are so many applications in modern mathematics, no? Even in the mathematics of that time. No? Okay, so you generate the first, the second, the third, and so on number of in the series. No? So it contained a detailed explanation of how the various quantities, no, involved in the computation. No? So meron siyang examples and computations how the detailed, no, computations are done. Okay. Now, when she published the work, no, Charles Babbage wrote her a letter. Okay, from university to. By the way, no, Ada Lovelace is in University of Oxford University, and Charles Babbage is from Cambridge University. No, do you follow? Abel is here, as the letter indicates. No. Okay, as the letter indicates, to Ada Lovelace, no, or maybe this is a source from University of Oxford. I'm not sure, no, Maybe that's it. Okay. So they exchange versions of table of the Bernoulli numbers. Okay. So they were debating, they were arguing on a certain part, like you are, tracing a program or debugging a program. They were looking at note G. So where's note G there? You're questioning, no? Okay, so it was lost anyway, no, according to Charles, and then, okay, and then Ada Lovelace, no, responded to the letter by making suggestions, okay, on the possible improvements, no, of the invention, no. However, no, Charles Babbage admired, okay, the work of Ada Augusta King. Michael Faraday, remember, was the physicist there. He wrote to Michael Faraday regarding and describing, no, the enchantress who has shown her magical spell, no, around most abstract sciences. No. They did not collaborate again. Okay, you follow? And what happened to Ada Lovelace was she got sick. No, she died at a very young age. Sorry, let's go back now. Medyo bumagal yung internet. Do you follow? So ito yung ano, no? Okay. This is Charles Babbage. These are the notes of Charles Babbage regarding the design of the analytical engine and the table of logarithms in the difference in engine, no, as implemented in the difference engine. Okay, how the gears were assembled together. Okay. Okay. So this is the same letter that Babbage sent to Ada Augusta King, Countess of Lovelace. So what happened after that? When Ada Augusta King, Countess of Lovelace, died at a young age, nobody paid interest in the work of Charles Babbage anymore. No? Ada Augusta King, by the way, was known to be the first computer programmer. And the work on Bernoulli series was known to be the first written computer program. Do you follow? The first written computer program. So what happened after that is it died, no? Computing technology entered into another dark age, no? Although not very long, no? Because it became popular again in the 1900s, this time in the US, early 1900s, because IBM was established, no? During the 1900s, no? And the vacuum tube diode was invented in 1904. And by the way, IBM was founded in 1911, okay, and was formally renamed International Business Machines in 1924. Now, the company became one of the largest manufacturers of computers, no? Early computers. Even now, no, the IBM PC is still in use, no. In 1912, no, from Great Britain, Arthur Poland developed the first electrically powered mechanical analog computer. Mechanical, but it's electrically powered, so there's a generator behind it. No? Vannevar Bush constructed a practical general purpose differential analyzer. Now, a very important event was, okay, in 1937, just before the Second World War. Kasi there was a debate, or there was an argument on who really invented the first digital computer in the US, no? John Van Vincent Atanasoff and Clifford Berry, no? Most of the improvements or developments came from the universities in the US, no? Like also in Europe, no? John Van Vincent Atanasoff and Clifford Berry, they are mathematicians. They are not physicists nor engineers, no? By the way, John Van Vincent Atanasoff and Clifford Berry are mathematicians and physicists. Si ano pala yon, si J. Presper Eckert ang mathematicians, no? They conceived of the ABC computer, known as the first automatic electronic digital computer. It resembles a lot of the of the analytical engine, except that many of the components are electronic, no? And it was based on the binary system. The only problem with that, with the ABC computer, is that it's not programmable. It was written to solve certain systems of linear equations, no? Particular problems. In 1937, no, Howard Aiken presented the concept of a mechanical computer to IBM, no? Where they bringing into action, okay, the principles used by Charles Babbage, no, to in designing the analytical engine, no? Nowadays, no, and later they assembled the machine in Harvard University, and they called it the Mark I. Okay, you follow? 1937, the Bell Laboratories, no? Bell Laboratories became AT&T, and they were the first to use relays, no, or like transistors, no. But this time, during those days, they are made of vacuum tubes. So 1940, no, complex number calculator, CNC, is completed. We don't know, but the first computer was developed by in Germany by Konrad Zuse in 1939. I think 1937. No? Konrad Zuse in Germany finishes the Z3 computer, which was the first, no, computer that was known to be binary and working commercial computer, no? But it was not recognized in the US. Okay. IBM, no, invented the Mark I, delivered it to Harvard University. The term bug was coined then in 1944. In 1945, in Pennsylvania, Moore School of Engineering, no, J. Presper Eckert and John Moakley, okay, developed the ENIAC. The ENIAC was a decimal-based computer with close resemblance to Babbage's analytical engine. Do you follow? The main difference is, okay, the ENIAC was built using electronic components. That's why it's called ENIAC. But we'll soon find out that it has a lot of resemblance. That's why a critique was done by Alan Turing later on the invention of the ENIAC and even the EDVAC, what follows. So from 1600s, no, to the middle 1900s, before the World War, okay. So that was the time when there's the difference between the developments, no, because when Ada Lovelace died and eventually also Charles Babbage died, nothing happened. Okay, everything came back again during the Second World War because of some important event. Okay. You can watch this, can you watch this video on the ABC computer? No? Who is Alan Turing? Anyone? The father of computer science and artificial intelligence. No? Siya ang nauna dito, no? The field of computer science and artificial intelligence. Navarro. Anyone else?
Sir, ako po, sir. Ay, sir, ako po, sir. Wala to, sir.
Who else? Sorry. Wala to, yes. Can you chat me if you're not able, you don't have mic? Okay. Ancheta. Okay. So anyway, no? These were the direct descendants, no? I've summed it up, no? So, and how, Conrad Suss released the first mechanical binary floating point computer in 1939, pala, no, not 1937. 1939, it's a mechanical computer. The memory is using physical state of rods, no? Magnetic rods. Unlike the analytical engine where the memory are stored using wheels in an axis. Do you follow? And in 1939, also, this is the beginning of the Second World War. An invention from Poland, it started as a Polish invention, was transferred to the US, to Great Britain. Okay, but officially, no, this was known to be invented by Alan Turing. Now, earlier I've asked you who Alan Turing is. No, he's the father of computer science and artificial intelligence. No? What was his invention? Okay, ito, yung bomb. Okay, it was later transferred in 1943 to the US. No? It's not programmable, no? It's cipher input, no? And the physical state of rods, no? Rods are used also the way. No? This is the bomb. No? It was, no, developed in the Bletchley Park. Okay, ito, Bletchley Park is actually a mansion, no? Somewhere in Great Britain, United England, no? Buckinghamshire, England. Okay, of the UK nowadays, no? Okay, what happened there? Kasi during the Second World War, by the way, no, Alan Turing became a hero of the Second World War. Why is that? One of the most important problems that the Allies had was to decipher the messages sent by Nazi soldiers, no, in the battlefield to each other. Okay, and also the messages sent over may telegram na kasi, no, over the radio and telegram of encoded messages from the Nazis, no. The problem is they cannot understand, they cannot interpret, because the Nazis are very good at encryption. Okay, the Nazis invented a very important machine used for encryption. It's called the Enigma machine. Okay, you follow ito. We don't need to study in close detail, no? But if you want, you can read or you can look at the video, no, regarding the Enigma machine. We have a link for that, no? So what is this? This is a typewriter. Okay, but before that, they will set a key, no? They will set a key before typing the messages. They will set a key somewhere such that when they type the messages, it will be encrypted. Okay, they will send the encryption and over the broadcast whatsoever, no, and then they will send the key to their walking spies, no, so that you can interpret. Okay, you can read the message only if you have the key. It's like the modern encryption, no. Okay, do you follow? So their biggest problem is how to hack the Enigma messages. Okay, they can intercept, they can receive the Enigma messages, but they cannot understand them. The Nazis are also, no, trying to hack their messages, but they were not able to do that because the UK are also sending messages to their people, to their soldiers in the battlefield. But this time, their codes were never hacked. They needed somebody as intelligent or as smart as Alan Turing. It was Alan Turing who cracked the Enigma code. Do you follow? Alan Turing broke the Enigma code, and it was so that the Allies were able to intercept, okay, the initiatives of the Germans, the Nazi Germans. Okay, they follow, and because of that, no, it was said that they were able to win the war 3 years ahead, no, because of the invention of Alan Turing, no, and the cracking of the breaking of the Enigma code. They were able to end the war earlier, no? Other than that, it could have taken a longer time. No? Do you follow? So that's why Alan Turing is very popular. Okay. Alan Turing, by the way, is a mathematician. No? He finished his mathematics degree also from Cambridge University. But Alan Turing, okay, did his PhD in the US. No? Do you follow? Okay. On the same University of John van Neumann, they almost no saw each other there. Kasi siya no finished his University of Cambridge PhD in University Princeton University, the same university where John van Neumann was teaching mathematics. Okay? Si John van Neumann is what? The inventor of the stored program concept, no? Of the modern computer. No? So si John van Neumann stayed as a professor of Princeton University from 1930 to 1933. He later became involved in the invention of, in the industry, no, the invention of so many computers. While Alan Turing did his PhD in mathematics also in the same university during 1938. He obtained his PhD there. Okay, just before the Second World War. Okay, then he was recruited by the British government. Okay, in the agency called Government Code and Cipher School at Bletchley Park, in, okay, you know where the place is. This is Britain's code breaking center, where he invented the bomb, the computing machine called the bomb. Okay. Now, what was the purpose of the bomb? The bomb was to hasten the computations needed in order to crack the code, because it will take them days, okay, before they are able to crack the code because of the computations required, manual computations required. So they invented a calculator that will aid them, no, to perform the mathematical computations faster. Okay, so it was called the bomb. Do you follow? In 1939, Hewlett Packard was established. No? Okay, do you follow? It was called the bomb. So Z1, Z2 were invented in Germany. Okay, I think Z3 was commercially produced in Europe. No? Now in the US in 1942, John Vincent Atanasoff and Clifford Berry from Iowa State University invented a machine called the ABC computer, a Atanasoff-Berry computer. It was not a programmable computer, but it had the workings of the Babbage engine, and primarily it is a binary machine. No, it's not decimal. So components of the ABC computer, can we do that? So if you look at the components of the ABC computer, it really is, no. It's the only problem is it's not programmable, no. Okay, but its components are similar to a modern computer nowadays, no. Okay. Hindi naka no. Okay, so it has an ALU, it has a counter, it has a set of registers, no? Like the ingress and egress axis. Do you follow? It's really like a modern computer, no. Now, during those times, no. Okay, and at the same time, by the way, no, Mark I was invented by Howard Aiken, no, at the University of Harvard University, no. Howard Aiken of IBM, electromechanical. It was then that the term bug was coined. Okay, a jargon, no? A jargon was added. It's called bug because the story was there was a time when one day that the Mark I did not function well. It's because they discovered that a moth was caught in between the gears. No? Do you follow? Now, in 1946, no, ENIAC was produced by J. Presper Eckert and John Mockley. Okay, at Penn State University. No, Penn State University is very popular. It's where Trump came from. No, diba? Wharton School of Economics is in Penn State, and then there's another school. It's called Moore School of Engineering. It's also in Penn State University. That is where J. Presper Eckert and John Mockley were teaching. No, they were professors, and they invented the ENIAC. Now they tried to patent the ENIAC as the first, okay, computer. Digital. It was not digital. It was decimal, but they patented it as the first electronic computer. But later, no, it was contested. No, a court. They were sued in court, no, for patent violations. No? I will tell you the story later. No? Who really was the recognized inventor of the electronic computer in the US? No? There was a contention between Atanasoff Berry, okay, J. Presper Eckert, and John Mockley. Three parties were contesting, no, for the invention of the first electronic computer. The third was John von Neumann from Princeton College. No, they all come from universities. No, so Atanasoff and Berry came from Iowa State. Presper Eckert and John Mockley came from Pennsylvania State University, and John von Neumann, the third party, came from Princeton University. They were all competing against each other to be recognized as the inventor of the first electronic computer. Okay, Manchester Baby in 1948 was developed in the UK as a follow-up of as an upgrade of the bomb. This was after the war. So the picture is this, no? Pagkatapos, after World War, no, the scientific community, many of them are racing to invent the first electronic computer because they already have seen the work of Konrad Zuse. Okay, and they have seen the work of Alan Turing earlier. Do you follow? So there are three parties contending. No? Atanasoff and Berry, J. Presper Eckert, and questions, and John von Neumann. Okay, do you follow? Now, what did Alan Turing during the time? What did Alan Turing comment? What did Alan Turing say about the competition that they had? Because they were claiming to be the first, no? Okay, they were claiming to be the first, no? After the Second World War. So Alan Turing, one of the founders of ACM, ACM is the journal, no, where scientific and mathematics results, mathematic researches are published. No? So this Alan Turing published a critique of the three parties. No? So he addressed this. No? I did not name them literally, but he addressed this to Atanasoff, Berry, Presper Eckert and Mockley, and John von Neumann. Okay, this is what he said. No? The idea of a digital computer is an old one. Why is that? Because the parties are claiming this is a new invention. Do you follow? That what they had are completely new. So Alan Turing may criticize them. The idea of a digital computer is an old one. Okay. Charles Babbage, location professor of math at Cambridge from 1828 to 19, planned such a machine, no? Called the analytical engine. It was never completed. Okay? But Charles Babbage had all the essential ideas that can be found in their machines. No? His machine at that time was not a very attractive prospect. No? The speed with which would have been available would be definitely faster than a human, no? Making computations, manual computations, but something like 100 times slower than the Manchester machine. He was talking about the Manchester Baby. Do you follow? The Manchester Baby, which was invented also by the same group, no? Alan Turing's group, after the Second World War. Okay. So it's 100 times lower than the Manchester machine. The storage was to be purely mechanical, using wheels and cars. But this is what he said. No? The fact that Charles Babbage's analytical engine was to be entirely mechanical will help us rid ourselves of superstition. Because if you say that you are the inventor of the first machine because it uses electricity, it's according to Alan Turing, that's superstition. That's unfounded. Okay, do you follow? Since Babbage's machine was not electrical and since all digital computers are in a sense equivalent, we see that the use of electricity cannot be theoretically important. Okay, so it doesn't mean that they were using electronic components that theoretically they're important. What's the important was the design behind it. Of course, electricity usually comes in where fast signaling is concerned, no? And fast signaling is needed. So that it's not surprising that we find it in both these connections, no? In certain computers at the storage system, it's mainly acoustic, no? But of course, that's wrong. Electricity is very important in the storage system. The feature of the using electricity is thus seen to be only a very superficial similarity. If we wish to find such similarities, we should look rather for mathematical analogies of the function. That is because he invented mathematical models corresponding to computers, including the analytical engine. No? So Alan Turing is known to be the first, the inventor of mathematical models for computing. Okay. In fact, he invented the Turing machine, telling all the inventors that all our machines can be reduced to this form, the Turing machine. Okay? Grabe, no? Very, very dashing claim. 1950s. So, what happened to Alan Turing? Anyone? He died at a very early age of almost like Ada Agosta King. After their work at the Bletchley Park, Alan Turing was sued in court for a crime, for something which was considered a crime during that time. He was sued for indecency. Nowadays, indecency is not a crime. People will take you out. The police will take you if you are going indecent in public, no? But they will not bring you to court. Okay. Indecency is involving sexual activities with the same sex. However, no. So what they did was they egged, because Alan Turing was a very important personality after the Second World War. They did not send him to prison. The others were usually sent to prison. Instead, they gave him hormones, no, to possibly cure, because during the time being an LGBT is considered to be a sickness, a disease. No? So they gave them a hormone, a hormone, no? Okay, called used for chemical castration as an alternative to prison. No, Alan Turing could not accept that. Okay, he took his own life. Okay, by taking cyanide. Okay, that's a very sad story. No? If he did not die, maybe more inventions would have been generated. Do you follow? Okay. So what happened during these times? No, of course, no, indecency was abolished. The indecency law was abolished. No? In 2009, no, Prime Minister Gordon Brown made a public apology in behalf of the British government for the appalling way that Alan Turing was treated. Okay, you follow? Queen Elizabeth also granted posthumous pardon to all people who were convicted of indecency. Do you follow? which means that if you were convicted indecent, you are now free, as if you did not do anything. Do you follow? They called it the Alan Turing law. Do you follow? In apology to Alan Turing. Do you follow? So that's the story, no, of Alan Turing. Now, Alan Turing, okay, was later recognized by BBC, no, British Broadcasting, as the greatest person of the 20th century. Okay, here's the Wikipedia, no. So in 2019, no, aired a series on BBC trying to make research on who is considered to be the greatest person of the 1900s, no? So nandito si Nelson Mandela, Margaret Thatcher in different fields. There's Ernest Shackleton, the explorer of the South Pole, Jane Goodall, no, the of the gorillas, Neil Armstrong, the astronaut, and then the scientists, no, Alan Turing, the code breaker, Marie Curie, Albert Einstein for the theory of relativity, and eventually, no, Alan Turing won. Okay, the honor of being considered as the greatest person of the 20th century. No? Here's the actual video of the awarding ceremonies. Okay.
The greatest person, the 20th century.
And that person is? Alan Turing.
Okay. Okay. What was he awarded for? Particularly the breaking of the Enigma code. Okay, because he was the Enigma machine in aiding the Allied victory in the Second World War. Do you follow? No, he was accredited the victory of the Second World War because it was through the deciphering of the Enigma messages that the Allied nations were able to defeat. Anong tawag doon sa kanila? Axis, no? The Axis powers. No? The Axis powers, Germany, Italy, and Japan. Okay? Do you follow? So the winner is Alan Turing. Sadly, no? He was maltreated by the British government themselves. Okay? So anyway, it was corrected now. Any questions? So you see, the picture, people are racing, to produce the first electronic computer, and Alan Turing commented on that, that no, you are not the first to do this. It's Charles W. Babbage. Do you follow? So during those times, there was a controversy because what was considered as the first computer was the ENIAC. May documentary. Can you look at this? The documentary of ENIAC. There's a controversy there. Okay, the controversy was very popular, such that it was only outmoded by the assassination of John F. Kennedy. During those times, without the assassination, the leading news was the ENIAC controversy. Okay, do you follow? So this is the ENIAC computer. I'm sorry. John J. Presper Eckert and John Mauchly at the University of Pennsylvania. It was begun in 1943 and completed in 1946, intended for use by the US military. Do you follow? So this is the ENIAC, It's electronic machine based on decimal numbers. Okay. Do you follow? When was the first computer invented, Okay. Ito kay Charles W. Babbage. But when was the first electronic computer? Initially, it was considered, ENIAC was considered to be, except that there were controversies. Later, the first electronic invention of an electronic computer was awarded to Atanasoff and Berry. And then the invention of the store program concept, was awarded to John von Neumann. Okay, and eventually, J. Presper Eckert, the patent to the electronic computer was not awarded to anyone. Do you follow? hindi na award. So that's the main reason why, during those times, any company could invent or could produce its own computer without any patent violations. Do you follow? And one company was very lucky, took advantage of the patent issues, the pending patent issues, and produced computers, okay, and released them, commercially, produced computers commercially, and they became a tech giant, That's IBM. IBM took advantage, because Presper Eckert and Moakley were sued in court, during that time, for patent violation of the electronic computer. So the patent was withheld, and it was never given anyway. It was withdrawn by the court, and IBM was able to produce computers without any patent violation, and they were the recipient, of the large computer industry, computer market. Sila ang nag-gain. They invented computers that sold commercially. Do you follow? It's not Presper Eckert, not Van Neumann, not Atanasoff and Berry. No? So it's a sad story. They were competing, nobody won the prize. Another party won, it's IBM. Okay. Okay, let's look at the ENIAC first, The programmers of ENIAC were all ladies, It's because the ENIAC was developed during the Second World War. Men are all recruited. Most men are recruited as soldiers. They were sent to Europe and to the Pacific to fight the war. Okay. The design of ENIAC. Okay. Let's look at this. For input and output, ang output lang pala, The ENIAC was using an IBM card reader for input, and an IBM punch card for output. So it no longer uses the Jacquard loop. It was completed in 1945 in Penn State University and was supposedly the first electronic general purpose digital computer. Initially, ENIAC was not given a memory, but later, Burroughs Corporation invented a 100-word magnetic core memory. So 100 word, one word is how much? 10 digits during that time. Okay. ENIAC uses 10 position ring counters to store digits. So ring counters pa rin, it's now electronic, A ring counter is an electronic version of a gear. Okay. 10 position ring counters. It's like a gear, but this time it's a ring counter is a series of relays, to store digits, Its digit, it had 10-digit assigned accumulators, which used tens complement representation and could perform 5,000 simple addition or subtraction between any of them and the source, which means that, okay, unlike Charles Babbage, there are only 3 registers, Ingress 1, ingress 2, and egress axis, because they were using ring counters because it's electronic instead of gears. Okay, so ENIAC had 20 10-digit designed accumulators. Programming the ENIAC was done manually by setting switches and wires. There's no keyboard. Do you follow? Unlike the analytical engine, it doesn't take punch cards. It can only read an output and save input using IBM's card reader and puncher, but the program is set on a plug board. Okay, ito yung ENIAC ko. This is the plug board which is used to program the machine. Okay, do you follow? No? So here's a comparison, of the ENIAC and the analytical engine. For input and output, the analytical engine uses Jacquard's looms with punch card. The ENIAC uses IBM punch cards for input and output, card reader and puncher. For the processing unit, The analytical engine has 3 registers, 2 ingress and 1 egress that composes the mill, or it's called nowadays as the CPU. On the other hand, ENIAC has 20 accumulators using ring counters. No? Now, what's the difference between an accumulator and an ordinary register? This was the first term or coined during ENIAC. No? Diba, bug was coined in the IBM. Accumulator was coined in the ENIAC. Okay. What is an accumulator? It is a general purpose register which can be used both for ingress and egress. Do you follow? So pwede siyang input and output at the same time. That is why nowadays we have accumulators in our IBM PC because they can both be used for input and output. So you see the difference? During Babbage time, no? A register is either used for input or output, but not both. Okay? During the time of ENIAC, no? Registers can now be used for any of the 2 purposes, no? Either input or output or at the same time. No? Not at the same time, but if you can use it at input this time, output in another. No? The number system are the same. Fixed point, decimal. Okay? The decimal system complicates the whole design. Okay? The program is stored sequentially on punch cards and loaded through the card loop. Dito sa ENIAC, programming is done by setting switches and connecting wires on a plug board. The programmer is Countess Ada Lovelace, and these are the Blady programmers, no? In Penn State University. They are all women. The hardware was not implemented completely for the analytical engine. For the ENIAC, no, there's only one version, no? By the way. It composes 1,800 square feet. Ganito kalaki yung kanilang computer. It occupies the whole room. Okay. 18,000 vacuum tubes, 1,500 relays or transistors, 10,000 capacitors, and 70,000 resistors. It's very hot, no? Because of the vacuum tubes. The inventor, no, was Charles W. Babbage, 1837. J. Presper Eckert and John Mauchly in the US in 1946. Pennsylvania State University, Moore School of Engineering. Okay. They follow. So there's a resemblance. So the critique by Alan Turing made sense. No, this is not, the ENIAC was not originally designed. It's not an original design. Okay, it has the resemblance from the analytical engine. In fact, it has the resemblance of the ABC computer. They follow, which the court was able to declare, no? Okay, kasi si Atanasoff and Berry sued, no? Presper Eckert for the patent of ENIAC. The ENIAC was never given a patent. It was given initially and was withdrawn. Okay, or like that. No? Any questions? Any questions so far? So let's proceed with our story. Okay. Wala na pala, no? Tapos na tayo dito. Sa ENIAC, Alan Turing. No? ENIAC, History of Computing. Now, next meeting, we will proceed to a different age. No? The stored program concept. No? Pagkatapos ng ENIAC, what came were EDVAC and IAS. There's also another story there. Because EDVAC was an upgrade invented by Presper Eckert and John Mauchly. But this time, this is a binary computer. Okay? Binary computer siya. It's also stored program. Okay? When was it released? 1949. Ito yon, no? 1949 siya na-release. Okay? And by 1945, during the development of EDVAC, no? Remember, ENIAC was completed in 1946. No? John von Neumann of Princeton College made a 101-page document, published a 101-page document regarding the design of the EDVAC. Do you follow? The draft report on EDVAC. And the author is John von Neumann. Do you follow? This is the problem. If EDVAC is considered to be the first electronic binary computer, why was John von Neumann accredited the design as presented in his report, in June of 1945? And this report, it details the design of the EDVAC, but this report was never contested by Presper Eckert and John Mockley. They never contested the report. So this report was considered to be genuine. Okay? And John von Neumann was considered to be the legitimate author. Do you follow? Now, EDVAC was released in 1950. (1949) pala, no? Delivered. IAS was also delivered in 1949. There were two competing computers, EDVAC and IAS. Okay, IAS is developed in Princeton College, and EDVAC was developed in Pennsylvania State University. Kaya lang, why was John von Neumann involved in EDVAC? Because originally he was part of the team, and in fact, the report accredited him to be one of the original designers. In fact, if not the only designer of EDVAC. Do you follow? Okay. So, who really invented the first electronic binary computer? It was not accredited to no one. No? However, not Presper Eckert and Mockley nor John von Neumann. No? Nag-split sila eh. They started working together, but they eventually split. And J. Presper Eckert and John Mockley finished EDVAC while John von Neumann finished IAS. Okay, but the stored program concept, which was included in EDVAC, was the main component of the IAS computer, Institute of Advanced Sciences. That's why it's called IAS. No? So there are two competing computers, EDVAC and IAS. In our modern times, it's like Macintosh and IBM, no? But during those times, there's only EDVAC and IAS. It's a competition between Penn State University and Princeton University. Do you follow? So there are controversies, no? Okay, regarding who really. Anyway, Atanasoff Berry were given the credit of inventing the first electronic binary computer eventually. No? The patent of ENIAC was not released, and the invention of the stored program concept was accredited to John von Neumann. Do you follow? Okay. So my competition during that time, no? EDVAC and IAS are very similar. Okay, we will not describe EDVAC anymore, but we will describe IAS because it's the formal, no? It's the formally accepted concept, no? The stored program concept. And the author was formally recognized, no? Kasi ang EDVAC may controversies, no? Okay. Any questions so far? So next meeting, we will look at the IAS machine. Okay? Do you follow? Hindi tayo titingin sa EDVAC. Okay? Hindi natin nasali ang EDVAC dito, no? Wala pa, mga mechanical pa ito. After this, the mechanical period were the electronic period. So that's when ENIAC, EDVAC, and IAS, okay, came out. There were three important computers there. Remember, no? ENIAC, EDVAC, and IAS. Okay. Of course, ABC, no? ABC computer by Atanasoff and Berry. 1940s ito during the war. Okay. Any questions so far? So we are done with the mechanical period. Do you follow? Next meeting, we will start formally with the electronic period, and we will look at one particular computer called the IAS. Okay. We'll also mention what happened to ENIAC and then back. No? So any questions so far? So we'll not go further now because it will be a very complex story to look at the IAS. We will have assignments, no, for the IAS. Okay. Okay. Do you follow? So you will have another assignment next week. No? Sum, okay, and average with loop for the IAS. Factorial program with loop for the PDP level, the PDP one later. That's done later. And then jump instructions. Okay. Any questions so far? Okay, so hanggang dito lang muna tayo, no? On the next meeting, we'll start another era in computing history, no? The electronic era, no? The time for electronic computers, okay? Okay, Navarro, I've checked your attendance. Is there anyone else? Okay. Blanco. Okay. Blanco Christian, this is your first time, no? But anyway, you just watch the recording and watch the videos, no? Watch the videos, the story of Alan Turing, no? Ada Lovelace, no? Okay. You watch the videos, they're very educational. No problem, no? If you have problems with connections. Anyway, this is recorded. I will also upload this. Okay. So no questions. So we will dismiss early today. Okay, no questions. No new topic. The next topic is different, no, completely different. So remember your assignment now, due on Monday. Okay. There will be no more meeting between today and Monday. Okay. So bye for now. Bye everyone.
Thank you, sir.
Thank you,
Okay.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you,
Monday.
sir.
Thank you.
Bye,
See you
sir.
Monday.